Hello, statistics. I hope everyone's having a safe and warm day off today. We are going to continue on this screencast with 10.4 Day 2, other sampling designs. Hopefully you're formulating some ideas about our essential questions. Today we're going to be working mostly on how we can generalize from a sample to a population and why it's critical to know how data are collected. Continuing with our objectives on 10.4, we're going to start today's class by talking a little more about stratified sampling and cluster sampling and look at a couple examples of those. And we'll go on to something called multi-stage sampling, where you combine the two of them, and then finally finish with systematic sampling. As we're going through all of these, I want you to think about why it might be better to apply these sampling methods instead of just using simple random sampling. As I've said, simple random sampling really is the gold standard of sampling. So why is it sometimes we don't want to use that? And actually, I'll start with that question on example 1. You're trying to find out whether there's an interest in adding a salad bar to Providence's cafeteria. Food Services believes that females and males have different opinions about the importance of a salad bar. How would you adjust your sampling strategy to allow for this difference? If you'd like to look back through your notes and try to formulate an answer, you're welcome to pause the video and then restart when you're ready to talk about your answer. Because we expect that there is a big difference between males and females, you would want to stratify your sample. In other words, if I don't make sure that my sample reflects the proportion of females and males in the population, I could end up with a skewed or biased sample. So let's say that Providence really is 50% male and 50% female. If I'm surveying 140 students, and let's say 100 were male and 40 were female, that's not going to give an accurate representation of the population as a whole. We'd want to split that so the proportion is 70 males and 70 females. So what I might do is get a list of ID numbers from the counseling office or the dean's office, and then use my calculator to randomly choose ID numbers from the males, 70 males, and to randomly choose 70 females. So again, that would be drawing a simple random sample of male students and a simple random sample of female students, which would be proportional to the total student population. Continuing with that example and trying to find out what students think about the addition of the salad bar at Providence, we've considered both a simple random sample and a stratified sample, but we've run into another problem. It's simply too difficult and time-consuming to track down the individuals whose ID numbers were randomly chosen for this sample. Excuse my typo there. So how could you draw a cluster sample? How might that alleviate the problem, and what concerns do you have? Again, you're welcome to pause the video right now before continuing on. So we did talk about how students are naturally set into clusters by classrooms. Excuse me. You could pick, for example, a few gym classes at random and then survey all of the students or each student in that class. That would be a true cluster sample. One way I might do that is assign a number to all the gym classes and have my calculator randomly select 6 numbers out of all the gym classes, and those are the ones I'd want to survey. Other things to keep in mind is this would save time, and the teachers would help in making sure that the surveys are completed. Now, one concern that we might have, and you may have thought of this already, is in order to do this, we'd have to assume that gym classes are representative of the population as a whole. If we didn't think that was true, we might have to consider something else. All right. So just to review in your notes, stratified versus cluster sampling. In a stratified sample, we divide by strata. Those are similar groups like gender. So in our example, we divided into males and females. And then you want to randomly sample individuals in the groups. In the case of a cluster sample, we're going to divide by convenience. So like the students are already divided into classes. The name of the game in clusters is really just making your job easier and easier to sample the groups. Randomly select clusters to sample. So in our case, we randomly selected the classes to sample. And then you want to sample all individuals in the chosen class clusters. So again, in stratification, we're dividing by strata and then randomly sampling individuals in the groups. For clusters, we're randomly selecting the clusters to sample and then sampling all the individuals. I just bring this up twice because even though we're not doing a simple random sample, you'll notice that randomness is still a very important part of our sampling methods. And the next thing we're going to talk about is multi-stage sampling. Multi-stage sampling is sampling schemes that contain several methods. These are called multi-stage samplings. So suppose that we want to use sampling to find out how long sentences are in textbooks. We can actually do this in 3 parts. We can stratify by selecting each of the 6 parts of our textbook. We're going to select from each of the 6 parts or units. Then from each section, we can go ahead and use a computer or our calculator to select 3 pages from each section. Finally, if we want to add a cluster to this as well, we can look at every sentence on each of the pages chosen. And that would be an example of a multi-stage sampling to find out how long sentences are in our textbook. So back to our example about the salad bar, we decided to sample gym classes at random, but you're concerned about the difference in opinions between males and females. Remember, we had talked about that at the beginning. So how can we design a sampling plan that takes gender into account as well and still keeping it a simple plan that is easier to execute than the ID numbers? Well, we could still use our gym classes. It is easier to use a cluster of gym classes, but we could stratify by gender by randomly choosing a few boys from the gym classes and a few girls from the gym classes, then survey 10 students in each of those clusters. So how does this reflect the different types of sampling? Well, there's a cluster in that we are choosing gym classes. Stratifying this comes into effect when we talk about girls and boys. We're going to choose boys and girls gym classes since we're assuming that Providence is approximately 50-50, males and females. We'd want to pick an equal number of boys classes and girls gym classes, perhaps 3 of each. Then we're using simple random sampling. Rather than surveying every student in that class, we could actually use a simple random sample and randomly select just 10 students from each class. So in this case, we've actually used multi-stage sampling and used all 3 of the methods that we have introduced already. That's going to conclude our stratifying and clustering, but we are going to move on to our last type of sampling, which is systematic sampling. You've actually been exposed to some systematic samples already in some of our examples, not today, but in previous lessons. Systematic samples are when we choose every nth individual, so maybe every 10th individual, every 40th individual. Usually this starts with randomness as well. So in this case, you'd want to randomly select a number for the student that you're going to start with. So let's say my students are arranged alphabetically, and I choose to start with student number, might go into my calculator and it randomly generates 4. So I'm going to start with student 4 and then pick every 3rd student after number 4. That would be a systematic sampling that still takes randomness into account. Systematic samples, again, can be cost-effective and save time. It can be a cheaper alternative to simple random sampling. Again, if we're trying to track students by ID number, it might just be too difficult to do that. We may not have access to their ID numbers and names, so it might just be easier to assign the students numbers and then do a systematic sampling. So, examples of systematic samples: survey every 10th student who enters the building. Test every 50th car brakes on the assembly line. Count the words on every 80th sentence in this book. So let's see if you have an idea of sampling techniques. We need to survey a random sample of 300 passengers on a flight from San Francisco to Tokyo. Take a look at these examples, see if you can name the design. Right. So if you're picking every 10th passenger, your sampling design or sampling technique for this would be systematic. If we're going from the boarding list and randomly pick 5 from first class and 25 from the rest, that would be a stratified sample. We might be stratifying the sample because we are assuming that there will be different answers from first class and from everyone else, so we want to reflect the proportion of the population. Next up, we are going to randomly generate 30 seat numbers and survey the passengers who are in those 30 seats. That is just a simple random sample. And finally, we're going to randomly select a seat position, window, left aisle, center, etc., and survey every passenger who's in that particular type of seat. That's a cluster sample, and your big clue that that's a cluster sample is that we're talking about surveying every passenger in a particular part of seat, particular seat. Your homework for tonight is going to be on page 286, and I do believe I got the page number right on this homework assignment, but those are the exercises at the end of chapter 10. You'll be doing number 7, number 26, just the sampling strategy, not the bias, and number 30. If you have listened towards the end of this video, I will tell you that I will be presenting the answers to these at the beginning of tomorrow's videos. So